Okay, so here's we are closing to the end of our polymer solution characterization, particularly understanding the molecular weight distribution and measuring the different types of average molecular weight. So here we are going to want to talk to you about the gel permeation chromatography. Okay, we talked about osmotic pressure, light scattering, intrinsic viscosity measurement, and then the gel permeation chromatography we call the GPC, and in the polymer chemists, and then that's the one that we are able to measure the Mn and Mw and Mz and the ratio between Mw over Mn. We can find all the information at once, and the GPC is still quite prevalent in any of the polymer lab. And if I have to choose the one technique among all the things that I have here, GPC will be the technique, and then that's the technique that I need to emphasize more. Okay. So let me talk about, so first thing is about the historical perspective. And here is, so you can think about quote-unquote molecular weight analysis of polymers. It can be essentially viewed as something that before and after the invention of the GPC. That was the year of 1965 is a very kind of the iconic year for the polymer characterization because of the picture that you can find it here. Okay, so this is a picture that I think I showed in my introduction in the first class of here. This is a first Waters GPC seminar held in Cleveland, Ohio. Okay, it has many regions. Cleveland is sort of the center of the rubber industry at that time. So the polymer conference was, a GPC conference was held in those appropriate places. And then these people are holding this very long necklace, trying to say this is a very, very long polymer. This is trying to say, I guess, 100,000, which is that means you have 1,000 repeating unit on this bead, or what about 2,000 repeating unit if it's a polyethylene. And it's actually Dr. Bill Meyer was one of the keynote speakers at the first GPC conference as a scientist working on polymers. And this technique was actually invented by this person named John Moore, and he was working at the Dow Chemicals. And Jim Waters was the person that actually was a small company owner who provided the detector to the Dow Chemical Company. And then once the Dow filed the new way to characterize a polymer molecular weight distribution using organic solvent, through the polymer gel matrix, and they call it as a gel permeation chromatography. And then later the Waters bought this GPC patent from the Dow Chemicals, and then now the Waters Corporation became one of the very large companies, particularly when it comes down to the HPLC and particularly the GPC techniques. So I was able to find out the historical papers here. This is almost size of the refrigerator. If you look at this, the size of this, the GPC unit, I think if the person stand next to it, probably that's how tall the persons are. Okay, so so it is almost like a size of the big cabinet. And the cells are very big and so on. And I actually, this paper was talking about in those days, this instrument, they sell it, Waters Corporation, sell it at the price about the $12,000. And that is close to today's years, is about $10,000. And that's and they're using a lot of solvent because of the cells are very big, and then all the systems are just was not optimized yet. But it has a very significant need in the industry because of the difficulty in characterizing the polymers. And now these days, if you have a budget of about less than $10,000, you can have all the bells and whistles. So you can put some different detectors. You can put auto injectors, and this is a solvent delivery pump, and this, I'm pretty sure this is an oven or something, so temperature control, different types of detectors. And where this oven, there's a kind of different columns of GPCs, and I'm pretty sure there is some auto injectors. So you can inject many samples automatically overnight, so that you can have a very fast feedback on polymer sample that you do. So I would like to draw this the simple arrow diagram, and then let me just put a line there. Year 1965. That was a GPC invention. Okay, the first GPC patent was in the early 60s. So before GPC and after GPC. Okay, so this is what GPC invented by Dow Chem, by John Moore. And he essentially find out there is a correlation between the GPC elution time versus molecular weight, log molecular weight. Okay, so he find those correlation, and then he report that. So after this is essentially years, and this is what I call the GPC era for not year, GPC era for the polymer characterization. So actually, getting popular in the 70s and 80s, the GPC is in many labs. So before the GPC, I think that what you guys learn is still useful and still useful for other labs. And then to me, if I have to choose the key techniques, I would emphasize the intrinsic viscosity that allow you to measure the viscosity average molecular weight based on the Markov equation. That's still the most powerful one, but this is also I think it's sort of in a way is comparable to the GPC, because essentially both intrinsic viscosity measurement or GPC technique both rely on the standard references based on the absolute molecular weight determination. So people still doing the osmotic pressure measurement, people doing the light scattering measurement, right? You remember the R theta. And the beauty of this technique is this is an absolute molecular weight determination, absolute average molecular weight determination. So you can get Mn from here, you can get Mw here. So now polymer synthetic technique has advanced, so that the techniques of making monodispersed polymer was reported in about 1950s. The anionic polymerization was reported, and so now people has a collection of sample that is having a well-defined molecular weight, and then using this reference synthesis polymer that has been made into a monodispersed polymer, they use as a calibration standard to make this GPC characterization easier to be done. So GPC is once again, it is a relative method. Okay, so you have to that rely on molecular weight characterization. So there's a molecular weight calibration. That's really the sort of the weak point of the GPC, although it's very powerful. And from the GPC, you can essentially get the whole thing, molecular weight distribution. Once you know that, you can get MN, MW, and dispersity of the molar distribution. And most people reported these two values as essentially represent what is an average size of the polymer molar mass, and then also how wide the distribution of molecular weight distribution is. Just want to give you a refresher. So this is a typical. I just wanted to show you that this is quite important from the beginning. So when you're looking at the elution time, which is elution volume, which is milliliters, and then you can really find out. That's the relationship they find out, and so they find the relationship between these two later. And then what I also want to emphasize, which is I'm going to give you later in that, this is somewhere in here, so sometime here. That's a year of 1967, and there's a paper by polymer physical chemists, and many of them, and the most key person is Benoit, and he's the one that he actually did an experiment on GPC to bring out the concept about universal GPC. And this one is essentially finally give a meaning about the size-based separation. And I briefly talk about the effect of the size, essentially molecular weight times intrinsic viscosity. That's the size, right? And he later find out is related to the elution volume about this. Okay, and so therefore this get the name. What is called now is a size exclusion chromatography of a macromolecule. It's called the SEC, and it justifies this one. Okay, you separate things based on the size exclusion, and the size is a very important term. And what that means is, if you're looking at this, the molecular weight dependence correlation with elution volume, and I can put this as, for example, polystyrene. But if you, let's say, I have another calibration standard, I can find out this one is PMMA. They do follow the different trend because of their size in the solution, depending on the solvent quality. They swell in a different way, and so therefore the molecular weight for dependence on the elution volumes are not is specific to the species of polymer that you use to generate this calibration curve. But now, if you do the universal GPC plot, just like we call the Benoit plot, and then you will get to this all the data that VE versus now not just the molecular weight, but molecular weight multiplied by intrinsic viscosity. Okay, and I think is a log scale, and then you'll find out it collapses into the single line. So let's say this triangle is from polystyrene, and then this red dot is from the PMMA. They essentially follows the same line regardless of the chemical discrepancy of the polymer. So physical mechanism that supports what's happening in the GPC is actually based on their elution volume dependence on the parameter called molecular times the intrinsic viscosity. That is essentially coil size, and that's why polymer chain coil size, and that's why we got the name called the size exclusion chromatography here.